I'd now like to turn our attention to the chemical variables that control the duration of the growth phase of hair, the duration of that catagen phase, which is when that hair essentially recedes from the inside out, and the quiescent or semi-quiescent telogen phase. There are a couple of key chemical players here that we should all be aware of. First of all, the growth factor IGF-1, insulin growth factor 1, which is produced by the liver, but that receives stimulation from the brain and pituitary to be released, is a strong regulator of hair growth. And we can think of it as the accelerator on hair growth. So it does that by extending that anagen or growth phase for longer. It doesn't necessarily speed up growth, but it extends it for a longer period of time. In addition, cyclic AMP, which is part of what's called a second messenger pathway, in fact, cyclic AMP is a second messenger, is also a key player in stimulating growth of the hair follicle. Now, cyclic AMP does many different things in many different cell types in the body. It really acts, as the name suggests, as a messenger between signals that arrive at the surface of cells and transmitting or conveying those signals to things that happen deep within the cells, such as the turning on and off of various genes. So when you hear second messenger, don't let that confuse you or overwhelm you. Just understand that the whole process of getting signals from the outside of cells into the center of cells and controlling gene expression, for instance, causing a stem cell to continue to give off daughter cells or causing a hair cell to continue growing for longer, that whole process is a bit like a bucket brigade of handing off water or a bucket from one component to the next or along a chain. It's like an assembly line. I think that's probably the simplest way to think about it. So for sake of this discussion, IGF-1 is known to increase the growth of hair by extending that anagen phase, as is cyclic AMP. So those are going to be considered the accelerators, at least in this conversation. The brakes on hair growth are going to be the things that either shorten the anagen phase or that extend the catagen phase or this quiescent phase, which is the telogen phase. And the two major brakes on hair growth that we want to think about are PDE, which is a phosphodiesterase. Okay? Anytime you hear ACE, it's likely to be an enzyme, and TGF beta 2. All right? So this is a particular growth factor that somewhat counterintuitively doesn't stimulate growth. It actually stimulates lack of growth or shortens growth. So with all of that in mind, and please do also keep in mind that you don't need to remember all those specific terms. Just understand that there are some factors like insulin growth factor 1 that act as accelerators on growth, and there are factors that act as brakes on growth. We can start to think about why, for instance, half of all people by age 50 start to lose their hair. Well, they start to lose their hair because of something called androgen-related alopecia, which translated to English means testosterone and testosterone derivative-induced hair loss. This is true in men and women. So hearing that, you should probably be wondering the following thing. Young men have higher levels of testosterone than old men, right? Well, the answer is yes, although some older men in their 40s, 50s, even 80s maintain testosterone levels similar to many men in their 20s, but most don't. It's a downward slope starting at about age 40. How steep that downward slope is depends. Women too have testosterone. In fact, women have higher levels of testosterone than they do estrogen. That's right. A healthy woman has higher levels of testosterone than she does estrogen. However, women on average have lower testosterone than most men. Okay, so they still have far more estrogen and far less testosterone than most men, but the level of testosterone that they have within their body is higher than the level of estrogen they have. Androgens, such as testosterone and its derivatives, such as dihydrotestosterone, which will be much the topic of what we're getting into next, inhibit IGF-1 and cyclic AMP. Again, androgens such as dihydrotestosterone prevent the action of IGF-1 and cyclic AMP, which you just learned a few moments ago, act to extend the anagen or growth phase of hair. Which then raises the question, well, if young people, both male and female, have higher levels of testosterone than they do when they're older, why would people lose their hair when they're older and not younger? The answer lies in the conversion of testosterone to dihydrotestosterone. Testosterone, most people have heard of, dihydrotestosterone or DHT, is made from testosterone. There's an enzyme called 5-alpha reductase that converts testosterone into dihydrotestosterone in both men and women. Dihydrotestosterone binds to the androgen receptor at 5 times the affinity of testosterone. So it is the most powerful androgen in humans. And it is responsible for a number of things that we all really want and like, such as mental vigor, physical vigor, strength, healing capacity, drive, libido, and on and on. So DHT itself is not bad. So if we take a step back and we acknowledge testosterone levels are higher in males and females at younger ages as opposed to older, but as they get older, there is more 5-alpha reductase activity, which is converting more of that testosterone to dihydrotestosterone, and dihydrotestosterone inhibits hair growth by reducing IGF-1 and cyclic AMP. Well, then we should all be aboard why it is that by age 50, about 50% of people experience pattern hair loss. That is androgen-dependent alopecia. Okay, but translated to normal English is pattern hair loss. And in a moment, you'll understand why some people lose their hair from the crown region, in the back of the head or back and top of the head, whereas other people lose their hair in the front of their head, in the flanks right on either side of the midline, or maybe in the midline and front altogether. And that's because different people, depending on their genetic lineage, have different patterns of androgen receptors on their scalp. And the pattern of androgen receptors that you inherit indeed does come from your mother's side. And so this is what gave rise to the myth that if you want to know if you're going to go bald or not, just look at your mother's father. It doesn't quite work that way. In fact, if you think about the logic, you should really look at your mother's mother if you want to know your pattern of androgen receptors on your scalp. However, most women don't lose as much hair from their scalp, or they have ways of covering up the hair loss in their scalp because their hair is just generally longer, or they're using other approaches, so that you never really get a clear picture of what the androgen-dependent hair loss was in your grandmother. Okay? Now, we don't want to go too far down the genetics rabbit hole because, as you know, you can't select your parents anyway. But if you want to know why, for instance, I'm losing a bit of hair on either side of the midline in the front, it almost certainly has to do with the fact that I have a higher density of androgen receptors there as opposed to, say, on the crown of my head, where for whatever reason my hair seems to grow thickest. Other people lose hair on the crown, in the back and top, but not in the front, and some people lose it all over. Now you understand why hair loss occurs in certain regions of the body. You should also understand that the androgen receptors on the face are also what are responsible for beard growth. And this is where it can get a little bit tricky, but a lot of things will start to make sense if you can understand this and internalize this. If you have a high density of androgen receptors on your face, well then as your DHT levels go up with age, you will be able to grow a thicker and thicker beard. In fact, it is rare to see someone who can grow a thick beard in their youth, but not so much as they get older. In fact, the reverse tends to be true. So the pattern of androgen receptors differs between the scalp and the face and the back. Okay, on your back, you have androgen receptors, and their DHT stimulates hair growth. So if you know someone who has a very hairy back, or if you have a very hairy back, that means you have a high density of androgen receptors on your back. If you have a beard and that beard is thick, well, then you have a high density of androgen receptors on your face. However, a high density of androgen receptors anywhere on your scalp is going to predispose those regions to androgen-dependent alopecia or hair loss in those particular regions, which is going to allow us to understand why all of the rest of the treatments for halting hair loss and for stimulating hair growth, almost all of those center on inhibiting either DHT directly or 5-alpha reductase, the conversion of testosterone to DHT.